My name is Liesl Leroux, and during today's lesson we're going to be having a look at chemical systems. Now, chemical systems is one of those sections that many of the teachers will give to you guys to do either as a self-study or a research project. Now, I know from personal experience that often self-study becomes no study. So during today's lesson, we're going to talk you guys through the key concepts of what you must know in chemical systems. Most of the lesson will be focusing on mining, so that's in particular exploiting the lithosphere, but there will also be questions towards the end dealing with the atmosphere and greenhouse gases. Right, so let's have a look at the key concepts that we're going to be chatting about today. Number one, exploiting the lithosphere. So that means, what is there in the lithosphere that we want, or what are we going to do with it? Then mining, particularly in South Africa. Mining makes up a good 60% of South Africa's exports, so mining is really very, very important to us. Then we're going to have a look in more technical detail at how we actually extract the metals from the ores. Yes, we know we've got gold, we know we've got phosphates, but how do we get them in some sort of a usable form? So that is extracting metals from ores. The cost of mining, not just what does it cost to mine, but what is the long-term costs on the environment, on communities? So how does mining impact on our daily lives, and also how does it affect our future? Then the effects of mining on the environment is very, very important, because especially in the last, let's say, 20 to 30 years, we've become more and more aware of the fact that this is the only earth that we have, and if we don't look after it, and if we don't do things in a manner which is sustainable, then we're going to end up with not enough food for everybody on the planet. So it's very important that we look at both the positives and the negative effects of mining on the environment and society. In particular, we're going to have a look at gold mining and mining iron and phosphate mining, as these are some of the most important mining activities that go on in South Africa. They're also very important to the world. You guys will know that Johannesburg's nickname is Egoli, and this city actually was created because people were coming to Johannesburg to mine the gold. Finally, we're going to have a look at energy sources. So we're going to talk about what are the energy sources that we're using at the moment, what other alternatives are there, and also what are the effects of these energy sources on the environment. Right, guys, so let's get going. Okay. I said that we're going to be having a look at exploiting the lithosphere, so I suppose we need to know what the lithosphere is. Now, the lithosphere is the rocky outer layer of the Earth's crust, which is full of minerals of all kinds. Now, what is a mineral? Very, very important. A mineral is any naturally occurring inorganic substance. So an inorganic substance, you guys would have done some organic chemistry. Remember, organic substances are substances that consist of carbon, hydrogen, and oxygen. So the minerals are the inorganic substances, right? For instance, gold and aluminium are considered to be minerals. The minerals in the Earth's crust are found embedded in rocks. So we can't just dig out a whole lot of aluminium and dig out a whole lot of gold. These minerals are embedded in rocks and a mixture of different other compounds. So we have to have a look at how we're going to get these minerals out of the rocks. Now, a rock that contains a lot of a certain type of mineral, a high concentration, is called an ore. So if there's only trace amounts of a certain mineral in a rock, we won't call that rock an ore. It's only if there's enough to make it worth our while to mine it that we would consider it to be an ore. All right, now some important things that we need to know is that 3/4 of the Earth's crust is made up of only two nonmetals, oxygen and silicon. Now, the compound that oxygen and silicon are found in is called silicon dioxide, which is commonly known as sand. The rest of the Earth's crust is made up of mainly 6 metals, aluminium, and so forth. Right. Let's have a look at how we are going to get the actual metals from our ore. The main 3 methods that we're going to be discussing today is electrolysis, heating the metal with carbon, and then heating the metal itself. Now, the sort of method that we're going to be using for extracting our metal depends on the reactivity of the metal. Now, if you guys have a look on the periodic table, remember that as we go from the top of the periodic table to the bottom, the reactivity decreases. And the reactivity of the actual metal is very important in the method that we're going to use. The method that we will use to extract the metal from the ore depends, as I said, on the reactivity of the metal. Now, if we have a look at our elements that are more to the top of our periodic table, those are the ones that are more reactive, such as potassium, sodium, calcium, magnesium, and even all the way down to aluminium. These guys that are relatively reactive will be extracted by means of electrolysis. We're going to talk just now in more detail about what electrolysis is exactly, but electrolysis is definitely the most expensive way of extracting metals, but in certain cases, we just really do not have another choice. Then if we have a look at metals such as zinc, iron, and lead, these metals are extracted by taking the metal and heating the ore together with carbon. And then when we look at the very, very stable ones, such as gold, that are very unreactive, gold and also silver, gold and silver can be extracted from their ores by just heating the ore itself and then taking off the gold and silver from there on. Right, so these are the methods of extracting. Very important that you guys realize which goes with which. Electrolysis, expensive, but very, very useful for reactive metals. Heating ore with carbon, used for zinc, iron, and lead. And then the very stable metals such as gold and silver can be extracted from their ore by just heating the ore itself. Let's make a brief little summary of these 3 methods of extracting from the ore. I'm going to start off with electrolysis. Now, what is electrolysis? You would have dealt with this probably before once or twice in your life. What we do when we're doing electrolysis is we take the substance and we run an electric current through it. So obviously it'll first have to be pulverized and it will have to be dissolved. But the main important thing is that the fact that an electric current is run through this liquid will mean that the positive and the negative ions will split. So that's what electrolysis is. It basically breaks up a compound, splits it into positive and negative ions, and gives us the opportunity to take what we want from the compound. You can consult your notes for a little bit more detail. Now, the method of heating a metal with carbon, let's write that down, involves a redox reaction. Let's use as an example iron oxide. So iron oxide will be found in an ore, and there'll be enough of it to make it sustainable for us to mine it. Now what we do is we heat it with carbon or with carbon monoxide, and the following reaction takes place. The iron, which at the moment is a positive ion, will become reduced. So there we have iron on its own, and the oxygen part of the iron oxide will bond with the carbon or the carbon monoxide. You can use either. And that's, as you can see, quite an effective method. Carbon dioxide naturally occurs in the atmosphere, and there we've got our iron on its own. Now, just let's quickly talk about heating the ore on its own. Now remember, when we heat the ore on its own, it has to be one of the more stable elements. So definitely, out of all the three methods of extracting a metal from the ore, heating the metal on its own is the least expensive, because we just heat the ore and we take what we want from it. Obviously, in the case of heating with carbon, it's more complicated. Carbon monoxide is a gas that needs to be pumped into the system. Electrolysis, as you can imagine, also, our ore has to be pulverized. It has to be dissolved, and then a current has to be put through it. So we would, in any case, use whichever method is the cheapest for us. Right, so just remember that. Those are our three methods for extracting metals from their ores. Let's briefly have a look at gold mining. Now, gold mining is something that's very much part of South African culture. As I said earlier on, Johannesburg was founded because of all the people coming from across the world for the gold rush. Now, there's different methods for extracting gold. Very often gold occurs in rivers, not so much in South Africa, but in other parts of the world. In South Africa, we mainly focus on gold mining through deep shafts. Now, before we go into the nitty-gritty of mining, it's very important that we talk briefly about the cost of mining. Now, when I talk about the cost of mining, it's not only what is it going to cost me to get the ore out of the ground, but we've also got to have a look at the impact that mining has on the surrounding community. Now, there are definitely very big advantages to mining. Firstly, and very importantly, jobs are created. So people that usually wouldn't have had work now can work in the mines. And also it stimulates the economy. Engineers are needed. Roads need to be built to get to the mine. So all of that is very, very positive. The negative aspects are, of course, very, very high up the environment. Mining these days has to be done in such a way that the least possible damage is done to the environment. Now, once it has been decided that that an area is going to be mined, there's a couple of other things that we also need to have a look at. Firstly, what are the dangerous aspects of that mine? Is it safe? Now, mining is not a very safe thing as it is, but we've got, if the ore is located in an area where, for instance, there are earthquakes or where the Earth's crust is unstable, that is definitely something that we need to consider. The other thing that, especially in the case of coal mining, can be very, very hazardous is methane gas. Now, methane gas, CH4, is a single carbon gas, and it's of all of the carbon compounds, it is the most volatile. Methane gas explodes very easily, and one can also be poisoned by methane gas without even knowing about it. So that's a very important aspect to consider. In early days, before all of the electronics that we have today, what miners used to do in a mine is, with every shift, the miners would take a canary down in a little cage with them. If they saw that the canary died, they knew that it was time to get out of the mine, because the methane content in the mine at that point is too high, meaning that the miners can get poisoned and also that there's a chance of explosion. Right, so very important that we think of the impact of the mining, both the safety, the economic, and the positive impacts that it might have. Right, now let's have a look specifically at gold mining. Gold mining in South Africa predominantly takes place in deep shafts. Now, the Western Deep Mine in South Africa is, I think, the deepest mine in the world. So in our deep shafts, we're going to have a look now at the process that is followed to get the gold out of the ore. Now, the first thing that is going to happen is that the ore, which has been lifted out of the mining shaft, is going to be crushed and it's going to be milled until it's sort of in a fine powder. Then a process of cyanidization takes place. Now, it's important to remember that after the gold is crushed and milled, you can actually at this point see the little bits of dust, the little bits of gold dust rather, that have come out of the ore. But it's very difficult to pick out those little pieces of gold, and therefore the next process takes place. Gold is reacted with sodium cyanide, oxygen, and water. And this compound of sodium cyanide and gold is then formed. Now, at this point, this compound is a liquid. What we then do is we filter the compound so that we've got only the sodium, gold, and cyanide on its own. Then we add zinc to this process whilst bubbling air through it. Now, you don't have to know the whole chemical reaction, but what you do need to know is that zinc is more reactive than gold. And there's a rule that says a more reactive metal can displace a less reactive metal from its salt. You would have learned this in grade 10. So if you have, let's say, sodium on its own and then zinc chloride, because the sodium is higher up on the periodic table and therefore more reactive, the sodium can kick the zinc out of its salt, and therefore we will have NaCl and the zinc on its own. Now, it's that concept that's used when we add the zinc. Zinc is more reactive than gold. Most things are more reactive than gold. Gold is incredibly stable. And the zinc then kicks the gold out of this compound. The zinc takes the place of the gold, and then we have the gold on its own. After that process, the gold is then smelted down, and then it is refined. It's very important to know that all gold that is used on the world market isn't necessarily 100% pure. It depends very much what we're going to use the gold for, how pure it needs to be. So the gold that's used in computer components and those sorts of things are not as pure as perhaps the gold that's used for jewelry and so on. Right, so let's quickly summarize what we need to know about gold mining. Mostly in South Africa, it takes place in deep shafts, very important. The fact that it takes place in deep shafts makes it quite expensive. Then just the process of the extraction of gold from ore, crushing and milling, cyanidization. Remember, the cyanidization turns the gold into a liquid, and then we add zinc to that liquid so that the zinc can displace the gold. It is then smelted and further refined. Now, the process of mining gold is very, very expensive. As you can imagine, the equipment that is needed is expensive. And because a lot of the gold ore is so deep underground, that also means that expensive machinery and equipment is needed. Now, the risky part about gold mining is that the price of gold fluctuates greatly. At certain times, the price of gold is lower. At other times, the price of gold is higher. But the cost of actually getting the gold out of the ore remains relatively constant. So at times, it can be a bit of a gamble. At the present state now, in 2011, there's lots of world turmoil, lots of problems with world economies, and that's a good time for gold because people will, at times such as these, rather buy gold, something safe, something dependable, than buy shares when they don't know what's going to happen. Gold mining in South Africa has also created a couple of social problems. Now, what happens if a mine is put up somewhere, laborers have to migrate to that mine to work there. Now, very often, these laborers are then very far away from their families. Social problems such as drinking and HIV/AIDS are often surrounding these unnatural communities that are formed around mining. So just bear in mind the cost of mining. Yes, how much it costs to get the ore out, but also the social cost. The next type of mining that we're going to have a look at is the mining of iron. Now, iron is very, very widely used because, of course, iron is used to make steel, and steel is used to make tools, machinery, equipment, vehicles. It's used as reinforcement inside the concrete of buildings. It's used to build bridges. So iron mining, very, very important for development. South Africa is a large producer of iron, and most of our iron comes from mines in the Northern Cape. Right, now the mines, the processes of mining iron, there are two. We can either have shafts, which are similar to gold mining, or open cast mining. Now, again, we need to have some idea as to the process that goes into extracting iron from the ore. Now, the iron ore is called hematite, and hematite consists mostly of iron oxide. Right, so let's quickly go through this process. First, the ore is crushed, then it is smelted, and it's smelted in something called a blast furnace. It's called a blast furnace because air is blasted into the furnace from the side. Now, these are the reactions that take place inside the blast furnace. Firstly, we start with carbon, also known in the industry as coke. We oxidize it with oxygen to get carbon oxide. Then the iron is superheated together with the carbon oxide, and inside the blast furnace, the reaction that then takes place is a redox reaction. Iron is reduced from its positive ion to Fe, and the oxygen that was part of the iron oxide reacts with the carbon monoxide to give us carbon dioxide. So these are the two reactions that take place within the blast furnace. Very important. Coke, which is a carbon mass, is heated with oxygen to give us carbon oxide. That carbon oxide is then heated together with the crushed ore, and the redox reaction then allows us to get the iron on its own. Iron ore very often contains a lot of impurities, particularly sand, silicon oxide, we spoke about it earlier. Now, limestone is used to remove these impurities from the iron ore. Now, the chemical formula for limestone is CaCO3. Now, limestone can be broken up into calcium oxide and CO2. And it is this calcium oxide that reacts with the impurities, the silicon oxide, inside the blast furnace, and that drops to the bottom, and therefore removing the impurities from the iron ore. Let's have a look at the process that is followed to extract the phosphate from its ore, which is called apatite. Now, phosphate rock is found together with clay and sand. So what we do first off is we crush this mixture. Then we do a process called flotation. Now, the flotation will allow the phosphate to come to the surface together with the sand while the clay goes to the bottom. So therefore, we can scoop off the phosphate from this mixture. So very straightforward, really. Crushing and then flotation. After the phosphate has been removed from the water, it is then transported to various different plants where it is changed into the fertilizers that we use in our crops. Right, the final installment of our chapter on chemical systems involves having a look at the different types of fuels that are or energy sources that are available to us. The first and the most commonly used one is fossil fuels. Now, fossil fuels, coal is an example of fossil fuels, petrol is an example of fossil fuels. They're called fossil fuels because it really is fossils, dead animals, plant materials from millions and millions and million years ago, with the pressure that's being applied to it by the Earth's crust, turns into coal. Now, coal is probably the most commonly used energy source in the world. However, there are a couple of problems surrounding the use of fossil fuels. The first, and very importantly, is pollution. Now, most fossil fuels contain some sulfur in it, and the sulfur, when sulfur burns, and that happens in the process of burning any coal, when sulfur burns, it turns into sulfur dioxide. Now, the sulfur dioxide is a gas, and that's suspended in the air around us. When it then rains, the sulfur dioxide is dissolved by the rainwater, and that gives us H2SO3. Now, acid rain is a very big environmental problem. Acid rain changes the pH of our soils, making it more difficult for plants to grow in those soils. Also, the acid rain gets into our rivers and our lakes, and that affects the fish in the rivers and the lakes. So fossil fuels, a big disadvantage is the fact that there is a lot of pollution. Advantages is that we've used fossil fuels for so long that we know the technology very well. At the moment, there's still quite a lot of coal available, so in that way it is easy, but we must remember that fossil fuels are not renewable. In other words, I can't plant more coal. It took thousands and thousands and millions of years to make the coal in the first place. Once it's gone, there won't be any more. So we have to start thinking of other ways of generating fuel. Okay, the next one that we have to have a look at is nuclear power. Now, what is nuclear power? Nuclear power is when a nuclear reaction takes place, obviously in a controlled environment. The nuclear reaction causes heat. The heat causes steam. The steam turns a turbine, and the turbine turns a magnet, which creates electricity. It's much the same in the case of fossil fuels, except it's the coal that's heated to boil the water. Now, nuclear power is a very clean source of power. What do I mean by clean? We don't have the same pollution problem as with the acid rain, but nuclear power does have other very important disadvantages. Firstly, a nuclear reaction is a very, very powerful reaction. It has to take place in a very controlled environment, and if there's any sort of accident, radiation can take place, and people can get killed, it can cause birth defects, and all sorts of problems like that. Think, for example, of the Fukushima nuclear plant in Japan. After the tsunami, there were problems, and at the moment, they are battling to keep those reactors cool and to keep the radiation contained. Another big problem with nuclear power is that nuclear reactions have very, very long half-lives. So if we have radioactive material, we can't just discard of it easily. It has to be buried very, very deep underground in uninhabited areas. The advantages, as I said, of nuclear power is if we do it properly, it is actually quite clean, and we don't have the same pollution problem as we do with fossil fuels. The other advantages to South Africa for nuclear power is that South Africa has plenty of uranium, and uranium is the element that we use in the nuclear reaction. A typical feature of nuclear power plants that you guys will notice is that most nuclear power plants are situated close to the sea. The reason they are situated close to the sea, of course, is in order to keep the reactors cool, plenty of water is needed. So that's nuclear power. Next up is wind power. Now, wind power is not really something that we know too much about in South Africa, but more or less the same process takes place. The wind turbines is used to generate power. It's very clean. In other words, there's no pollution. The wind is free, but the disadvantages are it's not always windy. And secondly, these huge wind turbines are very ugly to look at and could be a great hazard to the bird life around us. Similar to wind power, I'm going to talk quickly about wave power and solar power. Both wave and solar power, again, are completely clean. There's no pollution problems. Wave power, using waves to generate power, unfortunately, is very, very expensive. So there's a definite problem with wave power. Solar power. Now, In South Africa, we've seen more and more of a move to solar power. If you drive around, have a look at how many houses have solar panels installed on the top of their roofs. Now, solar power is firstly very practical in South Africa because we have sunshine most of the time. So from that point of view, solar power is definitely advantageous. Also, it's relatively easy to install these solar panels onto buildings or onto roofs. You don't have to design the building from the start with the solar power in mind. A lot of South Africans these days are using solar power, not just because we're being environmentally friendly, but also because we want to save money, because electricity has, of course, become so expensive. The next fuel source is biomass. Now, what biomass means is you take an organic substance such as sugarcane and you distill that into an alcohol which could then be used as a fuel. Advantages of biomass fuel sources is that they are renewable. In other words, you can plant sugarcane and you can plant sugarcane again the next year, unlike fossil fuels that are not renewable. Finally, hydroelectricity is when the power of water is used to turn the turbines and set the whole process in motion. Problem with hydroelectricity is that in a country such as ours, water isn't freely available everywhere. We often have droughts, so it's difficult to use something like water to create electricity if we also need it to drink. So just a quick overview of our fuel sources. Fossil fuels, most widely used on Earth. Problem is pollution and the fact that it's not renewable. Nuclear power, clean but dangerous, and it has to be done very, very well, otherwise potential disaster. Then wind power, wave power, not really utilized in South Africa. Solar power being used more and more in our everyday households as well. Guys, really it's just necessary that you have a brief overview of what our different energy sources are, and most of the questions that you'll be asked will be relatively intuitive. You will be asked, for instance, what are the things that one must look out for if you are looking for a location for a nuclear power plant? Then you will mention things like it has to be a geologically stable zone, because we don't want an earthquake underneath a power plant. It has to be close to the water. Advantages, the fact that it's clean. Disadvantages, if something goes wrong, it typically goes horribly wrong. So really, just have a read through the notes, and I'm sure you'll be absolutely fine. Let's now have a look at the typical type of questions that we can expect on this section on chemical systems. The recovery of gold has positive and negative effects. Give one positive effect for the economy of a country, just one positive effect. Well, guys, there's a lot of positive things that we can think of with regards to gold. Firstly, it can be exported, therefore creating revenue for the country. So let's write that down. Can be exported. It can be made into jewelry. And I think the most, now guys, with the export, that means that we get foreign currency into our economy. That's very advantageous. And also just we can sell it. So it makes money for us. Anything along those lines, I think, would have been absolutely fine. Okay. Name one negative effect on our water substances. Now, on our water sources. Now, if we think about the mining of gold, we've got to keep on thinking about the processes involved and the chemicals involved. Now, we've said very often today, cyanide, cyanide. Guys, cyanide is toxic. Cyanide is very, very toxic. And if cyanide gets into our water system, that can be very, very problematic. So that's one thing that I can think of. The other thing is possibly also just the fact that mining gold uses a lot of water, and South Africa doesn't have very much water as a resource. So that would be anything along those lines would be fine for question 1.8. Okay. Gold can be used in each of the following situations. State the property or properties of gold that is illustrated in each case. Now, firstly, it says it is used to make jewelry. Now, I would say the fact that gold looks nice, that it's attractive, and that it's shiny is one of the properties, but also the fact that gold is very resistant. What does that mean? It means that gold it's not gonna break, it's strong, so attractive, shiny, and resistant would be fine for question 1.9. Let's look at the next one. Gold can be made into thin sheets that are used for decoration. Now, the property of gold that's displayed here is the fact that it's very malleable. What does malleable mean? Malleable means it can be turned into all sorts of different shapes because, of course, we can heat the gold and so on. Right, 1.11, next question. It can be used as heating elements in aircraft windows. So it can be used as heating elements in aircraft windows. That would show us that gold is a good conductor of heat. So a good conductor of heat. All sorts of uses of gold also coming out in this question, and very interesting, some of them. Gold is used to cover objects that carry corrosive chemicals. Now, gold is a very stable element. It doesn't react with anything very easily, and I think it's the fact that it's unreactive is what's displayed over here, meaning that it won't react with the corrosive substance, keeping it safe, therefore. So it's very, very unreactive. Right. When making jewelry, the gold is alloyed with, let's say, copper, silver, or nickel. So which property is displayed here? Now, the fact that we don't use gold in its pure state is because actually gold is quite soft. So in order for jewelry not to bend and change shape too easily, we have to make an alloy with copper, silver, or nickel. So I would say that it is soft, would be one of the solutions. But perhaps also the fact that it's expensive. If we make an alloy with silver, copper, or nickel, all of whom are less expensive, then the gold goes further. So that would be 1.13. And then our final question for question 1, electronic components and medical implants. Now, the fact that gold is used in electronic components and for medical implants is because it is highly resistant against corrosion. Because if one does a medical implant, you don't want to have to redo it every couple of years, so it's resistant to corrosion. Okay, guys, and that's the end of question 1. And what question 1 has done really is it summarized the whole mining of gold process for us. We've been asked about absolutely every step of the extraction of the ore. We've also been asked questions on some of the advantages and some of the disadvantages of gold. So really a lovely question and a good one to go through just before the day of a test or an exam, because it really tests whether you know what's happening in the gold industry. Right, let's have a look at the second question. The second question deals with phosphate and phosphate mining, and it's quite a tough question. Phosphate mining is propelled by the world's growing demand for fertilizers because, of course, we have to feed all the people on this planet. Open pit mines in Phalaborwa are used for rock phosphate mining. The following 2 reactions are used to transform rock phosphates into soluble phosphates, and we are given these 2 reactions. Identify the acids represented by X and the acid represented by Y. Now, the acid represented by X is sulfuric acid, and the acid represented by Y is phosphoric acid. So let's write that at the top there. Okay, let's have a look at the next question. Right. Despite the similar molecular formulae, the product CaH2PO4 twice formed in the two reactions have different common names. Write down the names for each of these compounds or for each of these products in reaction A and in reaction B. Now, the process in reaction A where we're using the sulfuric acid makes superphosphate. So I'm going to write that there, superphosphate. And superphosphate, of course, being a very, very important fertilizer. Now, in the second reaction, reaction B, and the difference between the two is, of course, that in the second reaction, I am using phosphoric acid. Remember, we said that Y is phosphoric acid. The product is triple superphosphate. Superphosphate. Now, guys, as the question says, despite the fact that they look the same and that their molecular formulas are the same, how would I know when is it superphosphate, when is it triple superphosphate? Well, I think we would have to have a look at the reactants in the chemical reaction. So if I'm starting with sulfuric acid on the left-hand side, it will give me superphosphate. If I'm starting with phosphoric acid on the left-hand side, that will give me triple superphosphate. Right, let's have a look at the next question. Next question, question 2.3 says, explain why rock phosphate is unsuitable for a fertilizer. In other words, why can't I just use the rock phosphate as it is for a fertilizer? And the reason for that is very straightforward. It is insoluble. Now, guys, in order for a fertilizer to mean anything to the plant, we have to be able to dissolve it into water so that it can be taken up by the roots of the plant. So an insoluble fertilizer is just not going to do the trick. Right. Question 2.4. Give a reason why phosphates used in animal feed must be absolutely pure. The reason for that is that impure phosphates often contain heavy metals such as cadmium, and remember that it can obviously not be healthy for the animal to ingest heavy metals, and it won't be healthy for us either, who later on have to eat the animal. So the reason it has to be absolutely pure is because if it's not, it could contain traces of heavy metals, which is bad for the animal and bad for the person eating that animal later on. Right, let's have a look at question 2.5. What is the biggest pollution problem that the phosphate industry in South Africa is currently facing? Give a reason for your answer and give a possible solution to the problem. Phosphates are one of the main ingredients in detergents. Now, when those detergents make their way eventually into our rivers, into our water sources, what happens is the presence of the phosphate, because it is a fertilizer, actually promotes the growth of algae, giving the rivers a very, very green look. And this is not healthy for the rest of the ecosystem. So we can say that the fact that phosphates are a major ingredient in detergents, when it gets to the rivers, it makes the algae grow, and that is what is problematic. Right, so detergents into the rivers, they contain phosphates. The phosphates make the algae grow, and this causes a problem called eutrophication. Right, so what is a possible solution to this problem? Well, I think, as far as I'm concerned, Firstly, we have to think more carefully of what we wash down our drains. People should be a lot more careful about just discarding chemicals into our water system. The other possibility is to look at cleaning substances that are perhaps a little bit more organic and more environmentally friendly. Right, let's look at question 2.6. Question 2.6 asks us to state one advantage of phosphate mining. Now, a definite advantage to phosphate mining is the fact that phosphates help us to make fertilizers. Fertilizers helps us to grow crops a lot more efficiently. We are also able to turn crops over quicker, meaning that we can plant more times in a year and therefore stimulating the food production in our country. Question 2.7. Name 2 other uses of phosphates other than fertilizers. Now, phosphates are actually used in toothpastes. It's used in washing powders. It is also used in baking powder and to make carbonated drinks. So let me write that down. Toothpaste, washing powder, baking soda, and in cool drinks. But definitely the biggest use of phosphates would be for the fertilizers. Question 2.8. Name the main phosphate ore. What is the name of that rock containing phosphate called? It is called apatite. Almost like if you're hungry. Apatite. Okay. Now, our final question is a lovely question because it's something a little bit different. It asks us to write the chemical formula of ammonium phosphate and then to calculate the percentage phosphorus in the fertilizer. So we're going to start off by just writing down the chemical formula of ammonium phosphate. That is NH4, there's our ammonium, 3 times, and phosphate, PO4. Okay, so there's the chemical formula for ammonium phosphate. Now, in order to calculate the percentage phosphorus in ammonium phosphate, what we need to do is we first need to calculate the molecular formula of ammonium phosphate. And you will do this using your periodic table. I'm just going to give them to you guys. Now, 3 times, because there's 3 ammoniums, the nitrogen, 14, plus 4 times 1 for the hydrogen, that's 4. Then the molecular mass of phosphate, 31, and 4 oxygens at 16 each. This gives me a total of 149. And now to get the percentage phosphate in this compound, I'm going to say, well, phosphate itself contributes 31 out of 149, and then multiply by 100, and that gives me 20.81%. Right, guys, so quite a challenging question on the phosphate industry, but again, like the previous one on the gold industry, a very nice question to go over prior to an exam, so to make absolutely sure that you've got all the components done. Our third question deals quite predictably with the iron industry. So we've already now had a question on the phosphates, we've had a question on gold, so now we're going to have a look at question number 3, which deals with the mining of iron. So let's read what the question has to say. Iron is removed from its ore by the following reaction. Right, so we've got iron oxide reacting with carbon monoxide, giving us iron and carbon dioxide. Remember, we spoke about this reaction earlier on. We said that iron gets reduced from its positive ion to iron over there, and the carbon monoxide acting as the reducing agent. First question, give the name of the iron oxide that is commonly found. Give the name of the iron oxide that is commonly found. Now, the name of iron oxide commonly found is hematite. We spoke about this a little bit earlier on. H-A-E-M-A-T-I-T-E. So that's hematite. Easy first question. Right, next question. In the above reaction, aluminium can be used instead of carbon monoxide. Explain why carbon monoxide is preferred to aluminium. Now, the first thing that I think about is aluminium is expensive, a lot more expensive than CO. The other thing with aluminium is aluminium also needs to be mined. So now you have to mine something just to be a part of the process of purifying something else. I don't think that that would be profitable. Another reason is the fact that carbon monoxide is actually a stronger reducing agent. So no aluminium, that would just be too expensive, and also carbon monoxide is a stronger reducing agent. The next question asks us to write down the chemical reaction that will lead to the formation of carbon monoxide inside the blast furnace. So let's write it down quickly. We will start off with carbon. Remember, it is called coke as well, carbon in this form. It is oxidized, it's reacted with oxygen, and it gives us 2CO. Right, so actually they were kind in this question because they gave us the more difficult equation, the one of the iron oxide reacting with the carbon monoxide to be reduced, and they just asked us for this one. Right, let's have a look at the next question. What is the function of the carbon monoxide in a blast furnace? So why do we need to have the carbon monoxide there in the first place? Well, the reason is because carbon monoxide acts as the reducing agent, helping us reduce iron from iron oxide, where it's got a positive oxidation number, into plain iron. So very simply, I would say it acts as a reducing agent, or carbon monoxide reduces iron oxide to iron. Right, let's have a look at the last question. What is the function of limestone in the blast furnace? Now, we spoke about that earlier on today. We said that limestone helps remove impurities from the iron. So especially sand, silicon oxide, the limestone removes the impurities out of the ore, and then the resulting compound is called slag. Right, so it's to purify. Let's have a look at the next question. Briefly describe the economical and environmental impact of iron mining in our country. Now, as far as economical impact is concerned, remember we said earlier on that iron is used to manufacture steel. Steel is used to make tools and machinery. It's used to make vehicles. It's used for concrete reinforcement in tall buildings. So the fact that we have a thriving iron industry means that we can do all of those things with our own iron, but we can also export it to other countries who might need it. So that would be one, well, probably a sufficient reason for the economical. Environmental, we have to always mention whenever we are dealing with mining, that mining involves chemicals, it involves a high usage of water, it destroys the natural environment, especially if it's not done very carefully. So from that point of view, it is a disadvantage, certainly for the environment, but economically, it's an advantage. Right, let's have a look at question 4. First, it looks like question 4 is going to be dealing more with the environmental issues surrounding mining. And the first question that we are asked is, what is a pollutant? Now, I would say that a pollutant is any substance that is harmful or toxic. So any substance that is harmful or toxic. Although it must be mentioned that any substance that is not where it belongs can also be considered a pollutant. For instance, this glass is not polluting the TV studio at the moment, but if it's thrown in the road, that could also be harmful and toxic to somebody passing by. So anything harmful or toxic is called a pollutant. Right, next question. Name 3 pollutants produced by burning fossil fuels. Now, we spoke about this just now, saying that while fossil fuel is still the fuel that we use the most, it is definitely one of the ones with the most environmental impact. Name 3 pollutants. Firstly, coal. Secondly, oil. And thirdly, gas. All right, and very often, remember, when we're burning fossil fuels, there will be sulfurs and all sorts of things that go up into the air, and remember, the acid rain could potentially be a problem. But for now, we'll just give them the 3 answers that they require. Let's move on to question 4.3. Question 4.3 asks us, what is acid rain, and explain how it is formed. So let's think about what is acid rain. SO2, carbon dioxide, nitrogen dioxide in the atmosphere. There is SO2, CO2, and NO2 in the atmosphere anyway, but excesses of those that are very often caused by the burning of fossil fuels, then it rains, and the SO2, NO2 is dissolved into the rainwater, therefore reaching the ground as an acid. Of course, causing the pH of the ground and the pH of our rivers to be more than it needs to be. They didn't ask for any specific equation, so we're just going to write down the process involved in forming it. Question 4.4 says, explain how acid rain can disturb the environment. Well, firstly, it gets into our rivers, changing the pH and making it difficult for plant and fish life. It also gets into our soil, changing the pH of the soil, making it difficult for crops to grow. And another thing that's interesting about acid rain is if you look at beautiful old buildings with nice carvings and things on, the acid rain falling on those buildings over years and years and years actually erode the buildings, showing us exactly how strong acid rain can be. Right, let's move on to question 4.5. Name the most important greenhouse gas and explain how it contributes to the greenhouse effect. Now, the most important greenhouse gas is CO2. And how does it contribute to the greenhouse effect? If we've got too much CO2, what it does is it traps the heat in our atmosphere, acting like a greenhouse, making it get hotter and hotter and contributing to global warming. So the most important gas, CO2, and it traps the heat, therefore causing the environment to become hotter and hotter. Right. Define global warming. Now, the definition for global warming has to include, firstly, that there is a temperature increase as a result of the greenhouse effect. Right, so global warming is a temperature increase as a result of the greenhouse effect. Right. Question 4.7. Coal is South Africa's main energy source for electricity production. Why do we mainly use coal? Because, well, the reason why we mainly use coal is firstly is because it's efficient. Coal works very, very well to produce electricity. We've also got lots of it, and we've been generating electricity using coal for many years now. So the technology is very much available to us. So I would say, firstly, we've got a lot of it. It works very well, and we already have the equipment and the infrastructure to use coal to create electricity. Question 4.8, write the general equation for the combustion of fuel. Okay, now guys, fuel in general is asked. We're not asked for any particular fuel, so I'm going to write fuel plus oxygen, and when any organic fuel is burnt, I get carbon dioxide, water, and of course energy is released. And it is that CO2, excess of CO2 that is contributing to the greenhouse effect. Let's have a look at the final question for question 4. Write an equation to show why the combustion of coal contributes to acid rain pollution. Okay, now I think in this case you could probably use either CO2 or SO2, but CO2 is the main product coming off the previous question. So carbon dioxide into water gives us H2CO3, which is of course acidic, contributing to that acid rain problem. Let's have a look at the final example question, question 5. Right. Question 5.1 says, explain in general how electricity is generated. So we're not asked particularly now in what do you do if it's nuclear, what do you do if it's fossil fuels, just in general. Now, in general, we need some source of heat. So usually I would say coal is burned. Now, the reason why we burn the coal is to produce heat. Why do we need the heat? We need the heat to boil water because the boiling of the water creates steam. That steam is then used to turn a turbine and the turbine turns a large magnet inside a coil. Large magnet inside a coil, and it is this turning of the large magnet inside the coil that produces the electricity. So it's very important that we note that in most of the conventional ways for generating electricity, we need heat at some point because the heat heats up the water, creating the steam, and the steam turns the turbine. Right, so in general, that would be the sequence that would be required. Right. Question 5.2, nuclear power is generated when a controlled nuclear reaction takes place inside a nuclear reactor, producing heat used to convert water to steam, which drives turbines and the whole process that we spoke about just now. Where are nuclear reactors usually situated, and why? Now, usually nuclear reactors are situated close to the sea. In South Africa, we've got a nuclear reactor at Coburg, which is in Cape Town, right, in the Cape Town vicinity. It's situated close to the sea because a large source of water is required. Why do we need so much water? We need the water to keep those nuclear reactors cool. That's very important for the stability of the whole situation. Remember, I don't know how many of you were watching the news, but when the tsunami hit Japan, there's a nuclear plant that was in great danger because of the tsunami hitting the surrounding area to the nuclear plant. A lot of the infrastructure was broken, so they weren't able to cool those reactors as effectively as they did before, and there's still great concern that could have a possible nuclear disaster or could cause a possible nuclear disaster. Right, so near the sea, and preferably somewhere where the geology is very stable so that you don't have earthquakes and things like that. Where is South Africa's nuclear reactor located? Now, I've already answered that one in the previous question. It is in Coburg, which is close to Cape Town. So let's write that down so you can see how to spell Coburg as well. Coburg, which is in the Cape Town area. Right, let's have a look at question 5.4. One of the disadvantages of nuclear reactors is leaking. Name 3 consequences of nuclear radiation. Okay, now nuclear radiation is absolutely disastrous. If one is exposed to any form of nuclear radiation, the first thing that can happen is that you can die instantly. So definitely, death would be a problem. If you don't die, you will probably have some form of cancer because of the way that the radiation has altered your cells. People that are pregnant could give birth to babies with serious birth defects. And the list goes on and on. So it really is, it's probably the biggest possible disaster is a nuclear disaster. And the other thing about nuclear radiation is we can't just make it go away. Nuclear reactions have very, very long half-lives, and anything radioactive will remain radioactive for a very long time. So it's not just something that we can clean up or put in a rubbish dump. So definitely very, very serious. Okay, let's have a look at question 5.5. What happens to nuclear waste? Now, well, hopefully it doesn't end up anywhere close to you. Usually nuclear waste is buried very, very deep underground in containers that contain the radiation to some extent, and it would be buried in a place where people do not live. So it's buried in underneath the ground, very deep underneath the ground, in special radiation-containing containers, and definitely not anywhere close to where people live. Describe the chemical property of nuclear waste that makes it so harmful. Nuclear waste remains radioactive. So the fact that it's, firstly, the fact that it's radioactive. The fact that it's radioactive causes radiation. And I'm also going to add to that, it remains radioactive for a very, very long time. One nuclear disaster, which you guys can look up on the internet, and you'll certainly be able to read quite a lot about it, is the nuclear disaster in Chernobyl. Now, a reactor exploded. That's basically what happened. And the land, for a very, very wide radius around that nuclear plant, is not inhabited by any people at the moment. And even though it happened many years ago, the levels of radiation is so high that it is just not safe for humans to stay there. Right, let's have a look at the final question of question 5. Give the name and the symbol of the element that is commonly used in the generation of nuclear power, and that is U for uranium. And remember, we said earlier on in the lesson that the fact that South Africa actually has plenty of uranium means that we could power more of, or supply more of our electricity from nuclear sources. Right, guys, let's have a quick look over the questions that you were given to do for homework. I'm not going to do them for you, but we are definitely just going to talk about them for a little bit. Question 1 says, list the 3 stages involved in extracting metal from its ore. So it's not talking about any specific metal. It's talking about what are the 3 things that I need to do if I've now decided I want to mine something, and how do I get to the ore? So we've got to think, how do we get the ore out of the rock? How do we get the metal out of the ore? We've got to also think of the refining. So that's our first question, nothing too difficult about that. The second question says, how does the reactivity of a metal influence the method of extraction? Now, this we spoke about right in the beginning of this lesson, and we said that, in fact, the reactivity of a metal is probably the most important thing in deciding how we're going to extract it. So let's have a look at a couple of metals. So we'll look at perhaps potassium right at the top, reactivity-wise, followed by sodium, also very reactive, calcium, magnesium, aluminium, and then moving on to iron, lead, and finally right at the bottom, below lead, imagine that you see gold and silver over there. So what have I done? I've listed my metals from least reactive to most reactive. And we said that the most reactive metals, it wouldn't just not be an option to heat these most reactive metals. We will have absolute explosions on our hands. So right down to about aluminium. The preferred method of extraction for potassium, sodium, calcium, magnesium, and aluminium will be electrolysis. Remember, in general, electrolysis involves pulverizing the ore, putting it in a liquid, sending an electric current through it, and that electric current causing the positive and the negative ions to separate. So that's for the more reactive ones. Then for the ones that are sort of in the middle, and I'm going to include in these, let's put zinc in here as well. Iron, lead, and zinc. Most of these are most easily extracted by heating, but not heating on its own. Heating together with either carbon or carbon monoxide. So heating with carbon or carbon monoxide. And remember, the function of the carbon is to act as a reducing agent, because in the ore, your metal is bonded to other things, like for instance iron oxide. So by reacting it with the carbon monoxide acts as a reducing agent, allowing the metal to go from positive to zero in oxidation state. Then it is only the very unreactive silver and gold that can quite simply just be extracted by heating. Right, so reactive electrolysis, not so reactive, heating, but heating in the presence of carbon monoxide to act as a reducing agent, and the very, very non-reactive ones can just be heated on their own. Right, so if that doesn't give you a clue, then I don't know what will. All right, the next question asks you to now suggest a method of extracting the following, and in each case provide a reason for your answer. Now, it's very important that you guys think about what I've just talked about, the reactivity of the metal. Now, if I want to extract silver from silver sulfide, I will have to think of the reactivity of silver. Silver is very unreactive, so take your clue from that. Right. If I look at question 2.2, they ask us to name 3 substances that are added at the top of a blast furnace. Okay? So we need to think, what do we need to do in this blast furnace? We need to have our ore, we need to have a reducing agent, and we need something to purify. So think along those lines for this question. I'm not going to answer 2.3 for you, very easy. Right, now the final question in your homework deals with the different energy sources. Fossil fuels, remember fossil fuels, carbon, all the naturally occurring things, coal that we use most often. Nuclear power is when we use uranium to make a controlled nuclear reaction to generate heat. Solar power, that's our solar panels. Wave energy, biomass, remember that biomass is when we use something like sugarcane or even corn. We distill it to make it into an alcohol which is used as a fuel. then wind energy, and hydropower. Hydropower is when the power of running water is used. Right, so which of the above? And now we are asked various different questions. Can have disastrous consequences if great safety precautions are not taken. Well, we've spoken about that at quite a lot of length today. And which of these sources makes use of PV cells to create electricity? Which is the most commonly used method for generating electricity in South Africa? Well, we've already said that coal is plentiful, so take your clue from there. What type of method of electricity generation makes use of windmills instead of steam to drive turbines? What type is produced by burning plant and animal substances? Plant and animal substances. Remember, I've just used the example of the sugar cane or the corn, so think about that. Which one makes use of a radioactive element? Well, that's not too difficult. And finally, is the major contributor to air pollution and ultimately to global warming. Now, guys, the reason why so many people are experimenting in so many different ways to make electric cars, to make all sorts of things that don't run on fossil fuels is because fossil fuels contribute greatly to global warming, and also remember that fossil fuels are a non-renewable source of energy. Right, so let's just quickly summarize what your little checklist that you need to make sure what you know at the end of this lesson. You need to know about the 3 major types of mining in South Africa. We're looking at gold mining, phosphate, and also at iron mining. You need to know that the method of extraction of a metal from its ore depends very greatly on the reactivity of that metal, so that's very important. Then you need to know the effects of all of these types of mining on the environment, but also the positive effects that it has on the people and the communities around them. Finally, we then had all of our different sources of energy. So you need to know that biomass is by burning plants or burning or distilling plant or animal material. And you also need to make a comment on the advantages and the disadvantages of each of these methods. We hope that today's lesson has been useful to you and that you now have a better understanding of the mining industry in South Africa.